So tonight we've got Marianne Heaslip, who won't be a stranger to many of you. She's been a long-time collaborator with Carbon Co-op over many years, and an occasional attendee and contributor at our EcoHome Lab sessions. So we're really pleased to have her join us tonight. So Marianne is the technical director of people-powered Retrofit, a retrofit cooperative based in Manchester, and she's going to be talking us through the changes coming in the home energy model. So over to you, Marianne.
All right, thank you, Matt. And yeah, apologies again for last month. Yeah, there's been some horrible bugs going around, and you wouldn't have enjoyed spending time with me last month, the way I was feeling. So yeah, Matt asked me to come and talk about the home energy model, which I'm guessing if you're on this call, you've at least heard of, because why else would you turn up on a Thursday night to hear about this kind of thing? My involvement in it, so I'm part of the quality assurance and validation team, alongside people at Etude and the University College London and Strathclyde University. And our job is not, we're not writing it, we're not making HEM, but we are testing it and kind of giving feedback on how it's working and quality assurance, that kind of thing. So that's, I suppose, to my involvement in this. I'm interested in all of this because I'm an architect by background, and I've spent the last 15 years doing a lot of work in retrofit, and as part of that, doing energy modeling, because you kind of, it's a very useful tool to have to work out what you need to do with buildings to improve their energy, carbon, comfort, performance, all of the rest of it. So I have some slides because I always work better with pictures, but feel free. I think if as I'm going through, because I realize I'm kind of a little bit in the weeds in this world at the moment, and I might use acronyms or say things that kind of don't make any sense to you. That's probably my fault and not yours. So if as we're going through, you kind of want to ask a question for clarification, please do feel free to stick your hand up. And then I don't have tons of slides, so hopefully it'll mean we get a chance for a bit of a discussion at the end as well, because I'm sure there'll be people on this call who have lots of interesting questions and opinions about energy modeling stuff. So I'm going to share my screen. Can everyone see that? Just to check. Excellent.
Yeah, that's all good.
Thank you. So I'm also, I should say, I'm also assuming that because this is EcoHome Lab, whilst you might not be overly familiar with home energy model itself or other particular modeling tools, processes, that you are relatively familiar with kind of energy use in building stuff. And I've tried to focus a little bit on some of the things that I suspect some people in this audience will be find interesting in the home energy model. But likewise, if there are things that come up that don't make sense, please just stick your hand up and ask. So I suppose to go back to the very beginning, some of you will have heard of this thing called SAP, the Standard Assessment Procedure. SAP is 30 years old now, at least. And its creation, some of its creation at least, and some of the things in it, and are lost in the midst of time. But it was created essentially so that when we started to get serious about how buildings perform, what energy they use, and what carbon emissions they generate, we had some standardized way of assessing that, so that we could see whether and it's specifically just for homes as well, it's not for commercial buildings, but it was to see, to demonstrate the building regulations. And it was always intended as that kind of regulatory tool rather than necessarily being a very perfect predictive tool. So it's always had that angle on it. We're now in 2026 on version 10.2 of SAP, shortly to be version 10.3. So it's undergone a lot of changes, a lot of iterations. There was a big change in it in like 2009-ish, where it expanded, got a lot more complicated, tried to take into account monthly calculations of energy use and kind of be a bit more realistic. But I think everyone kind of acknowledges that it struggles these days to do what we need it to with building energy modelling. Having said that, it's a steady state model that does what pretty much all building energy models do, including passive house planning package, all of the models that are used for this kind of thing anyway. And it's basically at the core of it, it's a heat loss model. So that you're looking at the building fabric and ventilation and infiltration and balancing that against gains from people living in the house, internal gains, solar gains, and from a heating system. That's kind of the real core thing that it's focused on. And in a way, with the home energy model, which is the thing that's coming in to replace it, that core approach remains the same, but as you'll see, it gets kind of quite a lot more sophisticated. For those of you who are interested and might know, Home Retrofit Planner, which is what People Powered Retrofit use in doing kind of retrofit planning, is a bastardized version of SAP, basically, or we kind of used SAP and then made a lot of changes to it, because we know that there are some things that don't represent existing buildings very well or represent how people live in their homes very well. So I've kind of come into looking at the home energy model having had about a decade of messing around with SAP to make it work better for existing buildings, and my particular interest is kind of existing homes. If you are really interested in this and where this is all coming from, I would very highly recommend going back and reading this report, which is from about kind of 5-6 years ago now. It was led by Etude, who are also the people who are leading the quality assurance and validation work on the home energy model. They did basically a literature review and a big piece of research talking to people about what was good about SAP, what was bad about SAP, what could be improved, and recognizing that we needed to change it to do something slightly different in a world where we're trying to achieve drastic reductions in carbon emissions. And I think one of the really nice things that they did, that if you're into this kind of stuff you may find interesting, is they mapped out what was going on in SAP, what all the different modules were within it. So, the kind of building geometry, the different kind of heat loss construction parameters, and then building services and how all of these things interrelate. Because this is one of the things that is quite, I suppose, tricky about modeling buildings, is that they are not they're not completely discrete systems. It's not one thing and then another thing and then another thing next to each other. They all interrelate. So when you're looking at your internal gains, it matters what you've decided to do with your hot water system and what's going on with your appliances and how all of those things interrelate. Representing that in a model is quite a challenge. And SAP, I think, especially because it had developed and grown over a number of years. There was I suppose it accreted a little bit. So there are things in it that definitely don't quite make sense because they've just kind of been added to, or a problem's been dealt with by adding a bit. Any of you who've been involved in any kind of software development or project development, I'm sure that whole dynamic is very familiar. I think the other thing is, in existing homes, there's a big an acknowledgement that SAP and EPCs, so energy performance certificates, don't necessarily give you the whole story. On that front, especially related to energy performance certificates, is a very good open accessible paper that I've referenced at the bottom there. I will definitely share the slides from this, by the way, as well. That shouldn't be an issue at all. But I'd recommend having a look at this paper, because I suppose it's starting to understand and acknowledge that when we're doing energy modelling, people sometimes talk about SAP being bad or not good enough at certain things, which, you know, it is weak in some areas, but it's also about being clear about the outcomes that you're trying to achieve. So when you're making an energy performance certificate, you're not necessarily, like, energy performance certificates are not designed to give you predictive information about what's going on in that building. I know that seems a bit weird and that they maybe should, but that's not actually what they're for. They're asset ratings to enable you to compare one building against another. So they have all kinds of normalized assumptions in them that mean that you can compare one building against another, and it doesn't matter who lives in them, how many people live in them, or, you know, what their heating patterns are. It's all normalized. In existing buildings, that presents even more of a challenge, I guess, because and you'll notice from that graph there, once you get to existing buildings that have poorer energy efficiency ratings, so down at your F and your G, what they find is that in reality, people use a lot less energy than is predicted by the EPC. And people sometimes talk about EPCs being at fault because of that. And I think there are some assumptions around things like infiltration that probably exaggerate heat loss a bit. But there's also a behavioural aspect to it, that if you live in a house with an EPC rating of G, you're probably not heating it to 21 degrees for 9 hours a day, unless, you know, you really don't care about your energy bills. So the work that Etude and UCL and others had done previously, they'd come up with some suggestions of what at the time was called SAP 11, what it should do. And the biggest one at the top of the list is encouraging the right decisions for the design and construction of net zero carbon ready buildings and the retrofit of existing buildings. So I suppose acknowledging that energy modeling for homes, it again, it's not purely about representing reality, whether you can even do that or not. It's about encouraging certain policy decisions and policy directions as well. And all of these models that we make, all of these tools that we make, they have, I suppose, certain assumptions coded into them. And when you go back and look at SAP, there are certain decisions that were made there around assumptions about heating patterns, for example, that in 1994 probably weren't true of the majority of the population, but there was something that people wanted to, well, the government wanted to encourage. So the model was kind of tweaked to encourage certain behaviours. And I think we have to be quite open about the fact that that's what goes on, because a model is only ever a model. It's not actually reality. So when you're making all of these decisions, you're kind of making them in that context. The other thing that's happened, I guess, over the last 10 years or so is a lot of the standards have caught up and become more sophisticated. There is an entire suite of energy performance buildings standards, which cover pretty much everything you could ever think of that you might need to model in a building, including some really weird stuff that I'm not sure I've ever come across in reality. But these standards were written and adopted in the UK before we left the EU, to support the delivery of the Energy Performance of Buildings Directive, so that there's kind of very high level, European level policy that's kind of supporting the development of these standards. And I've skipped over one because I know the crowd that we have at EcoHome Lab. If you're interested in that kind of thing, I would recommend having a look at this particular project, where someone's basically doing an open source implementation of the energy performance of buildings standards, which is quite, I think the building that they've got so far isn't massively complicated, which I'll come on to, like, why that's a challenge later. But I think it's a really valid, worthwhile effort, and trying to get it so that we're not, that this is like a pan-European project as well. So, you know, building physics doesn't change between Belgium and Spain. The climate might, and some of the construction technologies might, but the physics doesn't. So being able to share that knowledge is incredibly valuable. So finally we come on to HEM. So the SAP 11, as it was, reports were done by Etude, and government had, I think, took quite a bold decision, and I'm kind of glad that they did, but it's a big project. But they took a decision to develop, rather than just tweaking SAP, which they could have chosen to do, they took a decision to develop an entirely new modelling methodology, and they gave it a new name, Home Energy Model. The links on the slides there, I guess you'll be able to access them when you get them, but there's a lot of information that has been published on this that I obviously won't have time. I'll be able to go into all of it tonight, but if you're interested, there's kind of various consultations. I think maybe the second link on that page would be of particular interest to a lot of people on this call. That's all of the technical documentation. So it goes through, they're actually quite readable papers giving you an understanding of what the methodology is of each section of Home Energy Model. So I think the big thing that is different to SAP, where I was talking about before, the difficulty of modelling things that are very interrelated. With the Home Energy Model, I think one of the positive things about it is that they've made a very conscious decision to make it more modular. So the diagram there, which is done by Claire Murray at Levitt Bernstein, is trying to illustrate this. So there's an idea that there's a core calculation engine, which is very neutral, agnostic as to all of those policy things that I was talking about, or things to do with kind of specifics in given buildings. It's really focusing on just the building physics elements of it. So it's calculating heat loss through ventilation and conduction, and trying to take account of thermal mass and all those kind of things. And the idea is that that sits and has inputs fed into it, both standardized inputs, which what gets standardized probably varies, and user inputs that are specific to a given building or context. It goes through the core calculation engine and gets spat out at the other side with whatever outputs really you want to draw that are available from the core engine. So it's, so they're referring to this as core and wrapper. Oh, I'm sorry, Sean, I'm not sure. Can everyone else still see the slides? Sorry.
I can still see the slides.
You might have just need to change your viewing thing, Sean. Yeah, so there's this idea of a core and then a wrapper around it. And what that does is gives you quite a lot of flexibility, because it means that every time you change a use case, you're not having to rewrite the whole thing. You're just writing specific wrappers for it. So the two wrappers that are in progress are the Future Home Standard wrapper. So that's the kind of inputs and outputs that will go around this to demonstrate building regulations compliance for new build housing. So that has a whole set of assumptions around it, and also, because it's a regulatory thing, a set of normalizations to make sure that you're comparing like with like. And then there's the Energy Performance Certificate wrapper, which will apply to new homes, but also to existing homes, which in some ways is probably a lot more complicated, just because there's a lot more variety in existing homes. With the Future Home Standard, and that's where a lot of the kind of development has been focused so far. There's obviously things that we get in older homes that you just wouldn't put into a new home now. So certain types of heating systems or certain types of constructions that just don't really happen anymore. So they haven't had to consider those. But once you get to the EPC wrapper, you're having to consider all of the weird and wonderful variety that we have in our homes. But the thing about the wrappers and them being modular is that in theory, the core could then have any different kind of wrapper around it. So there could be a retrofit specific wrapper that lets you do slightly more predictive stuff with your home, so you can put in your own heating pad and that kind of thing. There can be wrappers that deal with national stock databases, so that you're doing that kind of analysis. And all of it's doing really, I guess, is articulating, clarifying what tends to happen with SAP at the moment, but not get acknowledged. And then that's when it all gets a bit muddy and confused. So the other thing that they've decided to do, which I think is fabulous and could be really powerful, but is also potentially quite overwhelming, I guess, for everyone, is that they're going to make it open source. Now, they haven't necessarily developed it as open source in the way that some people on this call would see open source. So all of the development isn't happening out fully in the open, but it is all going to be published on a repository. So you'll be able to go, all written in Python, to be able to go and have a look at it. It will, the core, at least, I think there have been versions of the core that have been published. I'm not sure if the link on there is working at the moment or not, but the latest version of the Future Home Standard and the core model that goes with that should be getting published soonish. So that should then appear there. So for those of you who want it, you can go and have a look and kind of play around with it in Python. That's not something I do. I'm reading the methodology papers. I'm not a coder, so I'd be really interested to know what people who do have coding expertise think of it all. So what that also, well, a decision that was made, and what that also enables you to do is, previously when SAP was being developed, what they did is they published a kind of specification document that was written, you know, in natural language and some calculations, and different software providers then interpreted that and made their own kind of software implementations of it. But what was always a bit of a struggle with that was that you get a specification and 3 different people will come up with 5 different ways of interpreting it. So you ended up with slight differences between the different software. And it was quite hard to control and hard to manage that. And it also meant that any update that you wanted to do would take ages, because you'd have to publish change the specification and then give time for all the different software organizations to update things. What they've decided to do is they're calling it energy calculation as a service. And they're going to have a single approved version of HEM for the future home standard, and then also for the EPC version. And there will be people who provide like a front-end user interface to this, but that will be talking to the same model. So you don't get that kind of difference between different implementations thing anymore. And it means in theory that changes and updates, so that you discover a bug, you should be able to fix it relatively quickly at one place, rather than having to notify 10 different software providers about it and write a specification and wait for all that to update. So that is quite interesting. ECAS, I think, is being written in Rust. I'm saying these words, I'm not entirely sure what they mean, but Anna's told me what Rust, that a software developer that we work with, kind of has explained Rust to me. But I'm not sure if, I think that might end up being published so that you can go and have a nosy at it as well. So I suppose the question is it better than SAP? From my involvement in the quality assurance and validation team, so I don't get to see everything, and I wouldn't claim to know all of the ins and outs of all of the code, but we have, as part of that, done quite a lot of testing, like various bits of sensitivity testing, comparative testing against other energy models, going in and doing kind of specific bits of testing around different elements of it, one of which is how it handles heat pumps. There's a little blog from Etude there that you might be interested in, but I think what they say in that blog is that it can model the behavior of heat pumps and dynamic electrical demand very effectively. We all know that that's really important for informing good decisions about what we do in our homes, what systems we go for, and what we prioritize in retrofit and all of that kind of stuff. And it can do that much better than SAP can. I think actually the dynamic stuff is probably better than PHPP as well, dare I say it, because it is kind of it's a half-hourly model rather than a monthly model, and because it treats, in this way, it's a bit more like PHPP as well. It treats the heating system in the home, for example, as a system. SAP tended to kind of make some blanket assumptions about things that are a bit more static, whereas with HEM, you're modeling like the emitters, the pipe work, the flow temperatures, the efficiency of the system, all as a piece. So you're getting a more, so it will pick up things like a system being oversized in cycling or undersized and not providing enough heat. So that, I think that's a pretty big deal. And sorry, I had to include the picture of Dom because I thought there was some kind of law about showing that with the heat pump. Never come to EcoHome. And you can see, so when I was mentioning before about the technical documents, this is an extract from one of them on the heat pump methodology. It's a simplified version of what's going on, but it shows you kind of all of the things that have been taken into account to try and better reflect the reality of the situation, which I think with heat pumps especially is important because they're less forgiving if you don't get the system right. So I think the other big difference with both with SAP and quite a few other modeling tools and things is that it's much more accurate at modeling air infiltration and ventilation systems. On the infiltration stuff, it's quite it basically includes some modeling of pressure differentials. So it will make it models wind loading, and if you've got a flat at the top of the building, it'll behave differently to a flat at the bottom of the building. It takes all of that into account, which is, yeah, it's pretty sophisticated in that respect. The other thing that I'm kind of interested in, and that there is some work being done at the moment on as well, is how you get from an air pressure test result to that kind of pressure calculation, because you get your AP50 number from doing a blower door test, but there's still some work that needs to be done to say, okay, well, what does that mean in terms of where the air is moving around? And there's also some thinking being done about how you, not necessarily every existing building especially might get a air pressure test done on it. So there's quite a big bit of work happening to review the data for how you make assumptions about existing buildings and how airtight they are, because I think it's one of the areas in which SAP pretty much definitely tends to overestimate air leakage. Myself and my colleague Gervais Mangwana, we've now air pressure tested quite a lot of existing buildings, and some of them are remarkably airtight, like better than stuff that's built now in theory. But and yeah, I think the other thing it's doing with ventilation that SAP didn't really do is it's taking account, it does this with pipe work as well, but it's taking account of duct lengths and including those kind of things in the calculations. Again, another document there. If you're really interested in this, go and have a look at the technical document on infiltration and ventilation. And then finally, the big decision that was made was to, rather than have a monthly model, was to go to a half-hourly model, so that it matches with, I guess, the half-hourly settlement that we have and half-hourly smart meter data. And it means that in theory you can model storage, generation on site, use. There's a lot of complexity to that, of course, because when you're modeling, you're making assumptions about people's behavior and all kinds of things that isn't necessarily terribly straightforward. But at least this gives you the facility to do that and have a play around with it. When it comes to things like EPCs, there'll be like a set pattern of behavior, standard assumptions going on. But as I said before, because of the way that the core model is set up, if you then wanted to build a wrapper around it that did some other stuff with that same facility, you could do. And they have, again, there's been quite a lot, I think, throughout all of this. Probably not as much as you would like to do if you had infinite time and infinite money. But there has been quite a lot of a review of the kind of evidence base for all of this, for all the different aspects of the model as well, so that you kind of, again, hopefully getting a bit closer to what actually happens in reality. I wanted to make a point as well, because it's going to be open source, and because it's a new thing, when it gets released into the wild in full, it's not going to be perfect. I think it's good, but not perfect. There will no doubt be bugs. There will no doubt be edge cases that haven't been considered, and that we haven't thought of how to model things yet. Because it's open source and because it's a public service, I guess the theory is that we can all contribute towards making it better. I suspect some of the people on this call would be, interested in that too, if it's on a repository that you can comment on. And the last thing I wanted to say was just to point out that there is a current consultation. There's been quite a lot of different consultations on the home energy model over the last couple of years, but there's a current one that closes next week that's specifically about HEM and the relationship of HEM to energy performance certificates and the reform of energy performance certificates. So quite a couple of interesting things in that around being able to, unlike RD SAP for existing buildings at the moment, reduced data SAP has quite a lot of limitations on it in terms of what data you can put in and whether you can override to better reflect reality or not. They're proposing a system that allows a kind of higher degree of override should you wish to take it, and also some different metrics so that it's not just going to be one headline SAP rating. There's going to be these different metrics from EPCs, and they're also talking about being able to include the heat transfer coefficient and data from SMETAs potentially as a kind of supplementary bit of data alongside this. So if you're interested in this stuff, I would really encourage you, and you want to have some influence, I would really encourage you to go and have a look at that consultation and put your 2 pence in. And that is it, I think. So I don't know if anyone has any questions or comments or thoughts, or if that's just too much modelling for a Thursday night.
Thanks very much, Marianne. That was brilliant, really useful, I think. I wonder if could you give us a couple of minutes on just those 4 breakdowns you gave of like the smart readiness, fabric-y, just because I think that's am I right in thinking there are now you get 4 scores or 3 scores or something? But oh, sorry, you're muted, Marianne.
Yeah, sorry. There always were 2 scores on an EPC. There was the kind of energy efficiency rating, the SAP rating, and the environmental impact rating. But people always only really paid attention to the first one, which was only really about not about carbon at all, even though it's used in policy around carbon reduction. It was purely a kind of fuel cost multiplier metric. So it was about how costly that building would be to run. With RDSAP, one of the issues was that some of that fuel cost data wasn't updated very often. So it slightly warped things going on with it. And likewise, I was saying before about kind of these things sometimes having incentivizing things. I think we all know with EPCs as they stood, things like heat pumps would get penalised sometimes because it was so focused on fuel cost. It made some other assumptions that meant that it wasn't a brilliant heat pump setup, it was assuming. So then it would cost you more money, then it would downgrade your EPC rating. So what they're planning to do is, instead of that, because acknowledging that it's silly, I guess, to use a fuel cost rating when what you're bothered about is carbon and things like that, that instead to have these 4 headlines, so that for different areas of policy, or depending if you're a homeowner and you're interested in different things, you can look at whichever metric is most relevant to what you're doing. So the fabric one is about the thermal performance of the fabric, its efficiency, so heat loss, space heating demands related. I think that they're proposing at the moment, it's a version of the fabric energy efficiency standard. So that's kind of fabric, ventilation and heating system related. Well, not heating system related, it's just fabric and ventilation. There's a heating system metric, and the purpose of this, which I think is quite explicit, is to move away from fossil fuel-based heating systems. So it's kind of giving brownie points to kind of super efficient electricity-based heating systems. So heat pumps are going to be the ones that do the best probably on that. Direct electric forms of direct electric heating will do okay, and anything that's kind of still fossil fuel based, including possibly hybrid systems of various kinds, won't do as well. And then the smart readiness is really about, because we need that capacity for storage, demand response, all of that kind of things, looking at that. I'm less familiar with that, and I think there's quite a lot of different ways in which that might play out, and they are just consulting on it at the moment. So, but I think if you have an interest in that, I'd definitely suggest digging into it. And then the energy cost rating is kind of what it says. It's going to be different to the old SAP energy cost rating, which was a little bit of a black box, but just an energy cost. So when you look at an EPC for a house, it's not going to be necessarily what you end up paying, but when you compare one house against another, which is really what it's for, you'll be able to see the difference between the two and which one might end up being cheaper to run.
That's great. Thanks, Marianne. Zizi, you've got a question.
Yes. Can you hear me?
Yeah.
Yeah.
So I'm wondering, the current EPCs aren't particularly good for really old buildings, like old stone buildings that are rubble filled. I've got a friend who's done a whole lot of retrofit and it didn't move his EPC at all. Will this be a more sophisticated model that's better for these really old buildings that are long before the modern ones?
Yeah, so there's a couple of things that the home energy model does that should help with that. Some of it around assumptions about ventilation and infiltration, some of it around assumptions about thermal mass as well. And with it being a half-hourly model, there are things in there that could potentially help. I would say that on your friend's EPC not changing, it really does, because the EPC rating was just that fuel cost thing. Whether that moves or not depends a lot on the measures that you do, and there's lots of things that you might do that are very sensible and that do actually improve comfort or mean that you've drastically reduced your heat loss, that weren't really acknowledged in EPCs. So until recently, you couldn't even put in the actual kind of air permeability rating for the property, it was just estimated. So if you had an existing house and then you did a load of air tightness work and you got an EPC before and EPC after, they wouldn't really change, which, yeah, isn't great. But that's, I think all of that has been acknowledged, and it's the reason for changes in the model, but there will also be since the core model changes that support better modeling for that. But then also in the wrappers, some of the assumptions and the inputs that go into it are changing too, which should help. Does that answer your question, Zizi?
Yes, I think that's helpful. And, you can insulate more, but then if you put in a heat pump, that makes your EPC worse. So you can have things that counteract each other.
Yeah, that should definitely change, because the way that heat pumps are modelled in home energy model is very different.
Thank you. That's useful, because EPCs haven't been fit for purpose for various reasons, but that's certainly one area.
Well, that heating system metric that's going to be on the new version of EPCs, that's exactly what that's trying to tackle around that whole heat pump issue.
Thank you.
Right.
So anyone else with a question for Marianne before I abuse my position and dive in with another?
Can I ask a question?
Yeah, please do.
How does the new model take account of the variation in COP of heat pumps? I mean, some are. I've got a heat pump with a monitoring system on it, independent monitoring system on it, and I've got a seasonal COP of 4. But I understand that surveys that have been done of existing heat pump systems can have a seasonal COP of about 2.8 typically on average. That's a very big difference between, and the other thing that I might comment on is I have a house where it's all electric, and everything I pay for, including charging the car, comes £1 a month, and the energy company pays me every year, pays back the rising credit. And that's a 1980s bungalow. And I also look after my aunt's house, which is a 1970s bungalow. And with solar and battery, I've got that down to £1 a month. And again, money is repaid because the credit balance goes up every year. So I'm just wondering, there's such a large variety, and even I just doubt whether the new model is how is it ever going to accommodate this variation? Heat pumps depend on how they're designed and how the plumbing is like under the floor and so on, the radiator sizes. There's so many variables.
Yeah, so on the heat pump question, it should be that because, as you know, that seasonal performance factor, or the seasonal coefficient of performance, whichever one you're looking at, really, they depend a lot on system design. So the design of the emitters and the pipework and the flow temperature and the speed at which heat's going around the system, all of that is something that to a large degree can be modelled in HEM. So the difference where you see poorer performing systems, it's often because that hasn't been thought about together, and maybe the emitters aren't big enough, or there's some other issue in system design. Because HEM models that should be picked up. So you will see a house with undersized radiators versus a house with radiator size, so that you can get decent efficiency out of the heat pump system. You will see the difference in the modelling results between those two. So hopefully, again, that will encourage better system design, because it's going to make it obvious, whereas it maybe isn't so obvious just at the moment, the impact that has, other than, really good work that Tristan and people do to try and make it obvious what's going on. On the question of variety, I think that's maybe some of you saw the announcement that some of this work, so originally HEM for EPCs was due to come in later this year. It's now going to be postponed until second half of next year. I think that's because they want to get this right, and the huge variety in our existing homes of different construction techniques and different heating systems and different ventilation systems and all of that needs to be reflected as far as possible in the modelling, and getting that right and even documenting and working out what it is that needs to be included takes a bit of time. So yeah, I'm not saying it will be absolutely perfect, but there are serious efforts being made to kind of accommodate and represent that variety.
Thank you. That's fine. Yeah, thank you.
So we have a couple of questions in the chat. Sean, you were first. Do you want to do that one live or or I can read it out? Well, or Marianne can read.
I can read it.
Yeah.
It's fine. I've just got the thing. So if there's a plan for training assessors, I'm not that involved in that side of things at the moment. I know that the need for that to happen is acknowledged, and some of the existing schemes out there, so people like Elmhurst, know that this has to happen and are, I think, preparing for it. The other thing that's happening is a hopefully quite decent set of guidance being written, because although previously with SAP there was the specification documents, and then various different scheme providers and people had to go off and write whole training programs. Again, because of it being a more, I suppose, more centralized model, some of the user guidance is being written centrally as well, so that might help and might speed things up. But yeah, it's going to be quite a huge, well, it depends. I think a lot of work is being done so that maybe what the information that you have to put in about, say, the dimensions of the building, there might be a bit more to it than there was previously, but it's an attempt is being made to make it so that it's not overwhelming and completely different and completely alien. So yeah, there will be a need for training, and it will be a big task, but there are efforts being made in the way it's being designed and implemented to minimize that as far as possible. Does that answer your question, Sean?
Great. And then Paul, you had a question?
Is there just one Paul? Is it me?
It's just you.
Yes, I just wondered whether HEM will be able to take account of the quality of installation and commissioning, which I believe hugely affects the performance of the pump and the results as a result.
Yeah, I suppose there's always this thing where there's always a risk of a gap between what was designed and modelled and then what happens in reality. I think that probably comes down more to some of the quality assurance and oversight stuff rather than I suppose the model can just represent what should be happening. If that then doesn't happen in reality, that's that's down to kind of building control, MCS, those kind of things. We have had, there's been some discussions about in existing buildings being able to represent things, say, for example, like cavity wall insulation that hasn't been installed properly, or and how you represent that. I think that's something that is being thought about. But yeah, that gap between reality and the model is always going to be tricky to manage.
Yeah, it's very difficult to assess the quality of an installation after the event, I guess, isn't it?
Well, I suppose there's a lot of monitoring and things that can be done, but it needs commissioning, especially. I think you need experts to do it, and sometimes independent experts.
Can I ask a question, Marianne? Can we play with it? Where do we like? Is there like a software implementation anywhere that's accessible? Can we do our own EPCs?
Not yet. But I think
a plan, or
well, I know a few people who've been looking at it. It's been a bit tricky to this point because the schema keeps changing. Because the core model itself so there are things continually being added and tweaked to the core model, and especially as we get into existing buildings where, I was saying before about technology that doesn't exist in new homes, like things like chimneys are quite rare in new homes, but we have to be able to model them. But yeah, I think that there will be. And people might know of one yet, because I know it's the kind of thing that, because some of the Python code has been out there, like in the previous version for a while. I wouldn't be surprised if someone's had to play with it already. And I know some of the house builders and schemes are probably have their own play around with versions.
Exciting.
But yeah, at the moment when we're doing testing, one of the things that Anna, my colleague, had done was help develop some of the like testing tooling so that we're kind of chucking multiple JSON files through so that you can do multiple iterations of different things. So but yeah, that's very, if you're up for editing about 20 different JSONs, then.
So any other questions, thoughts, clarifications? Go on, Richard.
Hello. Yeah, thanks for that. That was really good. So you described it as core module, and then you said there were wrappers around.
Yes.
I'm not sure I really understand what's meant by that. Is that basically like different user interfaces to input the data and then different format of output, or is there a bit more going on?
There's a little bit more going on in that there's some pre-processing and post-processing going on as well. So it's almost like there's a core model running in Python or Rust or whatever, and then there is feeding into that kind of other little bits of software. Not explaining it, I'm very technical, obviously. Other bits of software that basically take some of the standard assumed inputs and user inputs as well and turn that into something that the core model can use, and then at the other end kind of going through a post-processing thing and outputting things in a readable format. So it's that kind of core and wrappers analogy. It is a real thing, but the analogy, it's more talking about the structure of the software. And then beyond that, there will be user interfaces as well. Yeah.
Okay, cool. Thanks. Yeah.
I have another one for you, Marianne. Sorry.
No,
just I guess because we did some work on the smart readiness indicator policy thing in Europe. Sat on one of the boards for that, and it just got really bogged down in like, because obviously a wall is a wall and its material is its material. But if you go to a home and it has, an incredibly efficient system, which is all running off, someone's Google Home, or, how is that a feature of the property, or is that a homeowner implementation? And it's a real tricky one.
Yeah, I think there's, it is something that you come up against, like in things like cooking even as well, and assumptions around well, because I should have said as well, so appliances are modeled in HEM again in a way that they weren't modeled in SAP really. So yeah, those questions of what's building and what's not, definitely things that are being worked through. Electric vehicles come into that as well. Electric vehicle chargers, is that part of the building or not?
Yeah, and then especially when that car is also a battery.
Yeah. Yeah. And it does mean, I mean, I'm sure some people are very frustrated that we aren't able to just kind of implement a new, better working model right away, right now. And it's not actually necessarily like the technical stuff that, I mean, the building physics gets a bit complicated and some of the energy system stuff, but the stuff that actually takes the time and the thought is questions like that. It's kind of, which again, that's, you know, in a lot of design, a lot of software development, that's what you end up talking about, don't you? So how do you categorize things?
Yeah, absolutely. Paul, you had a question in there.
Oh yes, I was just wondering about these independent experts you mentioned for commissioning heat pumps. What are they called? What do they call themselves? Are they heating consultants, or I mean, how do I look them up?
Well, I think I know about two, so I could probably give you like actual names, but
You're possibly thinking heat geek, are you, for one?
no, I was thinking of actual individuals that I happen to know, but
All right, yeah.
but yeah, I don't. So the other thing that's happening at the moment is there's a lot of concern from government about consumer protection, and also big changes happening in the construction industry about how it's regulated and who's responsible for what. And I think an acknowledgement that some of the ways that we've been doing things for the last 20, 30 years that are all around like deregulation and self-certification aren't necessarily working very well.
Water industry being a case in point.
Yeah. So yeah, I mean, in theory, you should get your NAPIT and your building control and your MCS and stuff should be some assurance, but we know that doesn't necessarily come with full independent commissioning, and some of it's also to do with the way things are procured. I'm sure if you wanted to, as an individual, you could pay for someone to come independent to come and commission your system separately to the person that installed it. It's just that a lot of people don't have that cash. And oh, and Sian, on the materials, so for the model, the HEM model, Sian's just asked if there's a huge database of materials and who'll keep that updated as new materials are developed. For building materials, the model, home energy model doesn't necessarily care about materials. It cares about thermal performance. So if you've got the thermal performance data, you put that in. But for things like heating systems, there's the product characteristics database that's got all the different models of like ventilation systems and heat pumps and boilers and all that kind of stuff. That already exists, and there's an updated version being made of it to go alongside HEM, and it'll be down to basically manufacturers' supply information that goes into that database has to be to certain testing standards depending on which bit of kit you're looking at. That works pretty well for new buildings because obviously people want to be able to sell their kit to go into a new building. Where it doesn't work so well is for things like warm air heating systems that, you know, were quite popular for a bit in the 70s and 80s. And I think there's one manufacturer of those left. So they don't really have information in that database. So in those cases, there'll be kind of default data assumed for that kit.
Yeah, I think you're right on your point. Oh, sorry, go on, Zizi.
Another question. At the moment, we've got SAP and we've got the reduced data SAP. Will there be the equivalent in this home energy model? And how will that work? What sort of data will be reduced in the home energy model? Or is it broadly just the same as the same kind of restrictions in
So it is a bit different. So there is a, this is where I have to remember what we're meant to call certain things. But yeah, there is an existing buildings version that, well, it's another preprocessor. So when I was talking about the core and the wrappers, there's basically a preprocessor, little bit of software that allows you, it's designed in such a way that it can accommodate the fact that in existing buildings, it can be quite hard to know things about the building without taking it apart, and because you don't have all the original design information. So it allows you to kind of make sensible assumptions and restrict some of those assumptions. But what they're proposing, what's part of the current consultation, is that rather than with RDSAP, that was quite rigid in terms of like it kind of forced certain assumptions, and even if you had better information, you weren't always able to put it in. What they're suggesting, I think, is that if you, for example, have the original U value calculations and you know that they're sound and you've got evidence of it, or you've got better information about the whatever existing bit of construction or building system it is, that you can include that, which they'd already started moving that way with RDSAP, because they'd allowed you to add in your air pressure test results and you could override U values. I think a limiting factor on it was, I know what I got told was that people didn't like, I think this happens with the MCS stuff for heat pumps as well, people didn't like overriding the defaults because that meant they were more likely to get audited. But I think looking at this consultation, that's being acknowledged that that's not an ideal way of working things. So, but that's, again, that's not really the model. That's like the systems and things and quality control schemes that go around it. So, yeah, Zizi, does that answer your question?
Yeah, that's great. Thank you very much.
Eric, you have a question in the chat. Do you want to say it, or should we read it ourselves?
Read it. Can you hear me?
Yes, we can hear you.
Yeah, just read it, please.
Okay, so there will be there's a thing called the minimum energy efficiency standard for rented homes that will mean that you have to achieve an EPC of C or above. By more challenges to assessments, do you mean challenges from kind of landlords who don't?
Yeah, I was thinking of that. I mean, the thing is, I don't know what you can do at the moment other than commission another and pay for another EPC that may give you a different value, maybe better, maybe worse, who knows. But looking at the fact that you might, as an individual, be able to do the modeling yourself, not many people, but, you know, those who can, would that even be admissible as a challenge?
So as I understand it, though, there's going to be one core, one kind of energy energy modeling as a service central thing, you still, to produce an EPC certificate, I think you're still going to have to be a trained and accredited member of a particular scheme. So yeah, you can't just kind of do it yourself, and that's then auditable. And and I know, yeah, like it's not.
It's an invidious situation if maybe you understand it better than the assessor or the people who run the numbers later.
Yeah, I mean, that happens now, doesn't it?
Yes, I don't know what people do now if they really feel aggrieved by what they think is
I think
low.
You can, yeah, you can raise a formal complaint with the whatever scheme that assessor is a member of. I mean, you probably want to talk to them first and just make sure that they've got the right information and they're, yeah, it isn't just something that they've just missed. But yeah, it is tricky when there's potentially tens of thousands of pounds worth of building work hanging on some of these.
It would be nice if it were truly transparent, but it's with what the assessors do with their numbers.
Yeah, well, I think with the new metrics being suggested for EPCs, hopefully that should become a bit more transparent rather than it being that kind of separating that's a bit of a black box. You kind of not quite sure which way it's going to go. I think with what they're suggesting around the fabric and the heating system and the energy cost stuff, it's going to be much plainer figures, kind of potentially more measurable.
Okay, let's hope so.
Yeah.
Thank you very much.
I mean, that's what so if you're interested in that, respond to the consultation as well, because
yeah, that's a good point actually. Yes, thank you for thinking of that. I'll look at it.
Cool.
I'm really keen, Marianne, on this whole like centralized engine that does the calculation, and then the inputs don't need to change so much in a way when you make a change on the back end. Do you think this is going to mean the process of iteration is a bit more of an agile one? Because I know sometimes there are like years, aren't there, where people know that something's a bit wrong and there's a plan to sort it, but
I think that's the intention. Yeah, so it'll allow you to well, it'll allow government to make those updates kind of more frequently and be a bit more responsive. It still means, you know, to do that stuff, it needs to be resourced and someone needs to manage it. But it potentially facilitates that a bit better.
All right, great, thank you.
I think that, yeah, when you said issue, I did wonder about, because when you're we still have some questions about how quick it's going to be when you're doing individual assessments, because it's whatever it is, how many half hours in a year, 17,000 and something. It's doing quite a lot of computation, and it's not necessarily going to be immediate. That's it, yeah.
Cannot wait to play. Any other questions or contributions from folks? Okay, well, that's a sign that you've clearly covered it very well, Marianne. Thank you very much for that. So I have 1,000,001 more questions, but I'm sure I'll find another time to present those. I
was just putting the link from the consultation, and then also I'll put the link from the technical documents as well. And I'll happily share the slides. So yeah, I think it'll be interesting. I'm not yeah, be good to see how the government get on managing an open source software project.
Yeah, absolutely. And is there just, sorry, just
No, sorry.
so is there a sort of feeling of excitement about it? Is there panic, or like what's the mood?
Well, I only know the mood in my little bit of it, in the QA and validation team, but I think well, I think the blog from Etude probably says it best in that, you know, we've all come into this because we care about getting building modeling right so that we can tackle the climate crisis and make people's homes warmer and all that kind of stuff. It is quite exciting to potentially have a tool that enables you to do that better. So yeah, I'd say kind of there's quite a lot, especially on the existing building side of things. There's a lot of work to do. But yeah, I think people are generally quite positive.
All right, this is good. This is good. And it is, and so in terms of carbon, I guess it will work out average carbons over periods of time for inputs.
I think that is a live discussion.
Okay.
Because obviously you could, in theory, with a half-hourly model, have half-hourly carbon data. You're nodding and smiling.
Well, I mean, yeah, I think given, you know, the carbon emissions have changed by a factor of 3 during the day to day, and the price has changed by a factor of 10, depending on what half-hourly period you're looking at. It's yeah, as has been said, there's a lot of moving parts, isn't there? But
yeah, and I think that's, yeah, that whole thing about predictions being hard, especially about the future, is definitely true. So, and in a way, for the EPC and for the future home standard stuff, it's a little bit easier because you're just setting a benchmark that allows you to compare different buildings against each other and against the regulations. I think once you get into modeling to be able to give advice about kind of configuration of energy systems or retrofit plans, that kind of thing, that is more complicated.
Mm-hmm. Well, there's a quick last question from Eric.
I can't answer that question right now.
On that bombshell, we will probably draw the session to a close before Marianne says anything that will get her into trouble. So thanks very much, everyone, for joining us. It's really appreciated, and your contributions are appreciated as always. Marianne, it's been really super interesting. So I'm really glad we got this together. Really enjoyed it. Fascinated, and can't wait to hear more. And maybe we can have you back when you can talk us through the tool we can play with.
Well, I think it's so the next iteration of it should be published soon, and will be on that repo. So yeah, have a play.
All right, fantastic. All right, well, thank you very much, and yeah, look forward to seeing